Hi there. This is just a video about what I've been doing with the G5 recently, the Zoom G5. It's out of order. There'll be other videos about when I got it, the unboxing and stuff, and I had to fix it up because it was secondhand, of course, and it had been mistreated. The push buttons, or whatever you want to call them, the sort of normal guitar latch buttons weren't working properly. Um, the on-off power supply wasn't working properly. I had to reflow the solder on that. I guess it had been bent. And there's still a problem with the type buttons and the page buttons. I guess there's some diodes missing. So what I've been doing is playing with the SysEx, and I want to just cover a little bit about some of the reverse engineering on the file formats. So if you want to play along, download the code from here. Get yourself a copy of the Zoom firmware. In my case, I'm using the 1.2. If you have a G5, you'll see that there are two firmware updates, one if you're below 1.10 and one if you're after 1.10. So I'm using the 1.21. I'm not putting it in the GitHub for obvious reasons. That's up to you to get it. And there are some similarities with the ZDL pedals on the B1N. You get these on-off values inside the firmware. They're hex 30 bytes long, which is 48 bytes, and they encode at one point the FX name, the MIDI max, the MIDI default, whether there's a pedal parameter there or not. And I put that into this fx name.json. Yeah. I'll show you that in a minute. Then I took the PDF and I turned it into text, and then manually created the JSON from it, or my version of JSON to help. And so that has what we call the Zoom ID, which is when you look at the manual, they will say that effect number 0 is M filter, say, or whatever the hell they say, yeah. Whereas when you put the sysex into it, which I do here, you get a different value, and I call that the PID, or the pedal ID. So basically we have the the ID that if you put 0 in, you get on the pedal. You have the ID which Zoom considers to be the 0 effect. And then on top of that, there's some Z pedal effects, which I've made separate for the minute because I can't quite work out how to get them in the sysex. So in the actual directory structure, maybe we'll look at it raw. Hang on. In the directory structure, so in my derived data here, firmware data, let's get rid of that, sorry. So in my firmware data here, I've got, actually I just realized I'll make that a bit bigger. So let me just pause that a second. Okay, I made that a bit bigger. I keep forgetting on this lovely screen in front of me, it's pretty big, but by the time you look at the internet, it's tiny. So in the firmware, we have the executable itself, and then we look at the Python. So let me see, does the split one off on off do it? Let's have a quick look. I forget myself. No, I don't. Yes, no, that. Oh yeah, sorry, that does work. I'm being an idiot. My bad. Sorry, my bad. My keyboard's gone crazy. This is on off in hex. Yeah, so capital O, little n, capital O, little fff. So you look inside that binary and you pull out the DAT files. So let's have a quick look at the star.dat. And if we look at argument's sake more on, no, hex dump minus C for character on, off, let's look at 095, why not? And so this one is, multi-tap. So you see it encodes inside itself the name of the FX and then the parameter names. And this in here will be some indication of if it's a pedal parameter, if it's got a maximum value, and all the rest is 150 you can see there and 100 there if you read hex well, yeah. So we take the firmware and we split it into the DAT files, and then we feed those into the check me, I think it is. Let's just check that. Check me. And this one says, hey man, did I find an on-off? I did, great. So as long as it finds an on-off, it says it's 30 at a time, 12 bytes in a range, and it tries to pull out the name. And then it encodes the name into FX name inside the JSON block. Then it tries to find and what I did was a bit kinky. In the past, you see, I was doing all this stuff to try and find things. Then I realized a much better way is just go for an obscene amount of range, and then keep going until you hit an exception. And if you don't get a binary char inside the name, then you've probably spilled over the end. And that seems to work pretty well, actually. I had all sorts of problems trying to find the end of the FX, and then it dumps the final stuff out into the FX name JSON, which is why if we look at star.json, we should be able to see there's a whole load of spectrum burst and things, and these are not always mentioned in the inside the manual. So for argument's sake, let's look at ZNR. And so what I've done is encoded it's called ZNR, and it has the parameters threshold with a minimax of 24, a default of 9, and it's a pedal parameter. And more on this as we look at this later, because it looks like the G5 is a super machine for control. Yeah, you've got the Z pedal, you've got the standard pedal side. So you've got the standard up-down expression pedal. You can move it left-right for Z, and then you can stick another pedal in. I have a standard expression MIDI normal expression pedal in there, and you get even more control. The aim is to see, well, can this give me some clues on how these later zooms work when they don't have a physical pedal, okay? And then the level was 150, 100. So that's that side of it. Now then what I had was this one, fx.dat was the initial decomposition. So this is where I took the sysex and said, hey, inject 0. It says, oh, okay, that's mfilter. And I had to look through the manual and find out, oh, that's the same as Zoom ID. So the pedal ID is 0, the Zoom ID is 17. Then the vibe, pedal ID is 1, oh, that's 123. Z organ 2, that's 90. And then at one point I used some ridiculous numbers like 500 and 1,000 because these are throughs are turning up, and they're different incarnations of a through, but I think normally in Python it needs to have some unique um, parameter value, which I suppose it would be PID 124, but I'll keep them separate at a minute, okay? And again, these ones here turn up DT slicer fuzz monics or whatever, but you see, so we have that side of it. And now if we look at the G5 params, this was derived from the manual. So I took the manual in PDF into text. It's a real pain in the ass because the way they format it. And then I said, okay, they call it Zoom ID 1, and that's comp, and the description is that. And the range hint is because you get in the manual, you get this sort of stuff. There's a slight problem because you get little musical notes or whatever that don't come out very well. In fact, they don't come out at all. Whereas the minus comes out as some crazy Unicode 2013 character, which really messes your day up. Yes, you have to go and set that. And there's, I think UVConv was something that did it, or IVConv. I don't know. You can look it up. Yeah. So I've done the hard work there. So we know that we've got a name sense, a tone, and attack, and all that sort of stuff. Yeah. So this gives us some indication of hints. And then again, when we run this Python merge fx, so we read in, oops, sorry, my little mouse thing's going crazy today. There it is. So we read in the G5 parameters that I just showed you, which is derived from the PDF. Then we load in this fx's.dat, which is coming from the sysex ID. And what we want to do is to marry up the matching names and parameters. So we walk through the fx, we check if the fx name is the same as the name coming in from the PDF manual. And I did have to do a little bit stuff to make it consistent, yeah. If we get a match, then we try and find the fx names JSON, and then we try and make certain it's there. Then we try and walk through the thing. I did try to think about using this with key existence, but this works for me and it's pretty quick. So we walk through the len of the parameters and we get the parameter there. We walk through the len of the parameters from the manual and we check. And if they're matched, then we extend the update the JSON for the parameters. So this adds in the MIDI default, the MIDI max, those sorts of things, yeah. And then we add in the pedal ID, and then we dump this out into the merged. Then I open up the Z pedal, and this time I just go through the Z pedal and say, hey man, can you find a JSON loads of parameters the same name? And if you can, put it into the merge, okay? So if we look at Z5 merged, sorry, G5 even, I'll be good if I could actually read, wouldn't it? Merged pedal params. Then you see it says, oh, okay, Zoom ID 1 is comp with the description, this compressor, blah, 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 blah. Then the parameters are, it's got a sense with a range here, a pedal is a pedal parameter and a description. It's a default of 6, a max of 10 in MIDI. The next parameter is tone, 0 to 10, description there, max 10. And this is stuff that I found out one way, and then Munch found a much better way of getting it directly from the ZD2 effects. But these are neither ZD1s nor ZD2s as far as I can tell at the minute. They just seem to be built into the pedal. So this is so I can get this information out, which is all very well and good. So then what I'm working on now, and I'll be using this, is, for example, if we look at one of these, I don't mean to go on, I'm just trying to be sensible. Let's look at the exercise FX1. So in this one, I can create a Zoom sysex. I can turn the editor on. I haven't checked this in yet. I can then turn on, what's that, FXM on off. Yeah, I can turn off FX1 parameter 1 and it's now on. Then I can walk through the range of values and I can set the slot value. What does that mean? FX1 M. Yeah, so I'm walking through FX1, and this is how I would get this is how I would have got the what happens as you go from FX0, as in sysex0, sysex1, sysex2, and I would have written down on a piece of paper the what comes out in the mix, yeah, and that's how I would have generated that. What is quite neat, and I'll just use a bit more time here. There's a compare explore, is it Max? Explore. Well, let's look at explore volume, say, for example. So in this one here, we can say, okay, read in some args, max and mins, play with them. And what this does is it pulls in some information and does the difference of the processed MIDI, processed sysex values, and then it gives me some indication. And what I started to do was to get it to draw graphs. So I generate, for example, 1.1 is for a specific FX, and one of the problems as we just see is that the FX1 is not enough to FX1 parameter 1 is not enough to be totally specific, because all that means if we probe the space is we're looking at FX1. If we what we need to do is to find the maximum FX range for a specific parameter. So we want to find which FX gives us the max of parameter 1, which FX gives us the max of parameter 2, etc., which we can now do with the JSON, yeah? And that allows me to create these directed graphs. So what it means is that when you vary parameter 1, and that's all, it says, oh, okay, moving 1, 1 to 1 produces a change in memory location 1, sysex1, and you see the bottom bit is set. Moving a 2 will set these values here. So basically, what we get out of this is a series of JPEGs which show us some picture of how the thing changes, and then you can merge them together. So if we just look at FEH of total graph, then what we end up, sorry, it's going to be a bit small there. Maybe there's a way of making it bigger. No, options. Maybe it's options. Screw that, sorry. So what this tells me is that parameter fx1 parameter 2, fx2 parameter 2, so I set them all to the same fx here, fx3 parameter 2, fx4, etc. So all of the fx's for the second parameter, they influence byte 2, byte 14, byte 26, byte 38, and in effect, you see it's going up by 12 at a time. So that means that the first 8, and therefore I guess 96 bytes in the sysex are related to those parameters, okay? And this deck is just a way of drawing a bit pattern so that we have this bit set there, yeah? These ones here draw a different bit pattern. And again, there's this pattern of 12. And what I can do, I've got a better drawing, I haven't done it yet, is it shows me, for example, the first FX is effectively multiplied by 2. So when you put in a value of 1, you'll get 2 out. And what it means is the first bit is not used. It's used for something else, yeah, and we'll find out as we explore it. So this is how I can close the loop on the thing and get the information. The next stage is to load in those JSONs I've only just created today and use those to create the state of a pedal. So for example, when we look at a Zoom pedal here, we're loading in a ZSX and we're setting various things up. It says 297 parameters, and we know how to get the get the patches rather. So at the moment I had like available FX, and I think what I'll do instead is I'll just load in that JSON, and it will be a self-created array that we can search and do stuff. Yeah. So if we choose from the list, we'll be able to say, oh, okay, that's equivalent to Zoom ID X, and it's the same as sending sysex Y. And we'll know the parameter space and range. It doesn't really matter, but it just makes life a bit easier. Then we can render the buttons and have the thing up and running. So that's it. I'm just basically doing this stuff, and so that's where I am at the minute. Hope that wasn't too boring, but if you want to follow along, please do. It should work on a G. Anything in the G3s here is not the G3Ns. These are where you use Mundral's code and then my later code as well. These are for the older pedals, and I'll be honest, I really quite like the little tube boost on it. I think in the room it sounds pretty good. They're often in a bit of a state. You're going to have to do some DIY on them, but there is also Ash Base, which is worth looking at. That there, a lot of people have put together mods, and these things are built like a tank here, so you can screw. Be careful as you screw holes in them because you don't want to go through any critical components the other side. But you can add more buttons and things into it, and I really like the multiple pedal inputs to these things. It's pretty cool. So I'll be working on this, then I'll turn my attention back to the MS70 CDR. The same techniques for exploring the sysex should work quite well. And I know I'm rambling on here, I'm sorry about that, but what I'm finding is that the pedal parameters, you on the G5 at least, it makes it more obvious that you're saying, oh, I want the expression switch to be FX4, and then you get a choice of the parameters that respond to pedal. Well, we already know from this firmware that if we grep for pedal in G5 merged params, we can see, and maybe grep for pedal. Actually, we want to look for pedal colon true, and we'll stick that in single quotes to escape it. Then, yeah, the smart amongst, sorry, the people eagle-eyed against you, rather. I don't mean to be condescending. We'll see. I meant to do that, yeah. And now we can be able to find out, okay, PID 70 has got a pedal true in its level, yeah. So if we choose this FX of 70, then we will be able to set the expression pedal on a G5 to influence the output level if we so choose to, yeah. On this one here, which is bend, we can change the bend as well, yeah. And so this is all within a single their pedalment, yeah. So pedal MN pitch, whatever, gives us a couple of things that we can change. So we can change the bend or whatever. Up here we can change the bend again. So there's sort of the usual suspects, yeah. But it means that there is a way via sysex to set these parameters with a G5. And what's really interesting to me, I think, as I showed earlier, I've got some way of looking inside the total sysex now to see what parameters are influencing certain bytes in a more easy way. Well, some of the patterns that I see and areas that are changed are parts of a G5N or a B1X4, whatever, parts of that range that I've not seen to date. So I know there's data there. I don't know what it does, yeah. And so What I'm saying is that this seems to be hinting, oh, those are pedal parameters. Ah, didn't know that. So I'm hoping, but maybe I'm wrong, that we'll be able to get into there and do something with that. Anyway, sorry to ramble on. If you want to play along, please look at the code and have a lot of fun. Okay, cheers then. Bye bye.